Hi everyone. In this video, we're going to work through a Year 12 equations of circles question. And this question is from the AS sample paper. Now we have here a circle C with a center of -2 and 6, and it passes through the point 10 and 11. Part A of the question says, show that the circle C also passes through the point 10 and 1. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018, and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams, and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app, and you'll be able to access all of these 2027 predictions. Okay, so in any kind of question where you're trying to show that a particular point, so in this case 10 and 1, lies on a circle, you need the equation of the circle, right? So if we know the equation of the circle, then we can just sub in x equals 10, y equals 1. And once we do that, we can see if the equation is satisfied when we sub in those two values. So we're going to need the equation. So need equation for C. Now, since the center is -2 and 6, hopefully you'll be happy with the idea that the form for this equation is going to look something like this. So you're going to have x and then minus the x value of the center, so x minus -2, which is x plus 2 all squared. And then it will be y minus the y coordinate of the center, so y minus 6 all squared. And this is equal to the radius squared. So clearly now we just need to find out the radius squared. We need to find out what that number is. And what we can do to kind of visualize that, I mean, if we just do like a random circle there, kind of ish, the center is going to be -2 and 6 there. And then you've got this point 10 and 11, which we know for a fact is on the circle. So that's going to be like somewhere there roughly. So to get the length of the radius, we can just do Pythagoras, right? So the change in the x values squared plus the change in the y values squared, and that gives us the radius squared. So to find r squared, use Pythag. So we're going to do, change in x values squared plus change in y values squared equals radius squared. So the change in the x values, so we go to 10 and we started from -2. So 10 take away -2 all squared, and then plus 11 take away 6 all squared. So this gives us 12 squared plus 5 squared. So this gives us 144 plus 25, and this gives us 169. So that's the r squared. So therefore, the equation for this circle is going to be x plus 2 squared plus y minus 6 squared equal to 169. So going back to the question, we want to show the point 10 and 1 lies on the circle. So we're just simply going to sub x equals 10, y equal to 1 into the circle. So if we do that, let's just scroll down here. So we're going to have 10 plus, oops, sorry, I've written that in the wrong place there. Let's be a bit more careful and rub that out. There we go. So we've got 10 and then plus 2 all squared. And then we got 1 minus 6 all squared. So this will be 12 squared plus -5 squared. So then this gives us 144 plus 25, which is 169, which is exactly what we wanted as required. So just a little conclusion. So therefore 10, 1 lies on the circle. Perfect. So that's part A done. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Now let's go to part B. So for part B, we've got the tangent to the circle at the point 10 and 11 meets the y-axis at the point P. And then the tangent to the circle at the point 10 and 1 meets the y-axis at point Q. Part B, show that the distance P to Q is 58, explaining your method clearly. Now, obviously, this is a longer 7-mark question here, and it's a circles question. So in any kind of geometric sort of question like this one, may just be useful or helpful to draw a diagram. If you're not sure where to start, if you do a diagram, that may help get your brain into gear. Okay, so let's do a diagram. Let's do it on the next slide here. Okay, let's do a big diagram here. So we've got a circle like that, roughly. We've got our center, which was -2, 6, so kind of there. You've then got this point 10 and 1, which is kind of, sorry, 10 and 11, sorry, that one, kind of there. And then you've got 10 and 1, 10 across, 1 up, which is kind of there. We just try to roughly add in the axes. So the x-axis will be a little bit lower than that 10, 1 point because the y value of that 10, 1 point is 1. And the y value of the x-axis is obviously 0, so something like that. And then you've got the kind of y-axis, which is going to be roughly there, just to the right of the center, something like that. So you've got two tangents, okay? So we had tangents at both of those points, 10 and 1 and 10 and 11. Let's do this in blue. So you got like a tangent there, and then you got another tangent like kind of there. Now, if we just scroll back up again, what did they say the points were? So the tangent for 10 and 11 is point P. The tangent for 10 and 1 is point Q. So the top one is point P. That is P up there. And then the bottom one down there is Q. So yeah, we need to show that PQ equals 58. So once you have that diagram there, may just help you figure things out, okay? So how are we going to get that distance? Well, if we knew the y values at P and Q, then obviously we could just work out the difference between the y values and that gives us the distance, right? So we need the y values for those tangents or the y-intercepts. So let's just make a note of this here. I'll go back to black ink again. So we need y-intercepts for the tangents. So therefore, we need the equations of the tangents. So we need equations for both tangents. So once we've got the equations of the tangents, so in the form y equals mx plus c, obviously the plus c is the y-intercept, as you should know. So once we get the two plus c's, we can just work out the difference between them. Okay, so let's start with the tangent to the top one, 10 and 11. Okay, so tangent for 10 and 11. We'll start with that one first. Now, obviously, to work out the equation of a straight line, you need the gradient. Okay, so we need the gradient of the tangent, need gradient. And if you know your circle theorems, you'll know that the gradient of the tangent is perpendicular to the gradient of the radius. Okay, so you got like a radius there, and these lines are perpendicular. So to get the gradient of the tangent, you need the gradient of the radius, and then you will take the negative reciprocal of the gradient of the radius. So therefore, we need the gradient, which means that therefore we need gradient of radius from the center to 10 and 11. How would you work out the gradient of two, well, the gradient of 2 points or the gradient of a line? Changing y over changing x. Okay, so changing y over changing x. So this is going to be 11 minus 6, the difference in the y values, and then 10 minus 2. So this is 5 over 12. So therefore, gradient of tangent is negative reciprocal. So that would be negative 12 over 5 instead. So therefore, let's just scroll up a little bit, scrolled a bit too far there. There we go. So therefore, the equation of tangent is going to be y equal to minus 12 over 5x plus c. We just need the plus c. How can we get the plus c? We can just sub in the point 10 and 11. Okay, so sub in x equals 10, y equals 11 to get the plus c. Or you could use the equation y minus y1 equals m times x minus x1. You can use that equation too if you want to. That's fine. I'm just going to sub in the values here instead. So 11 is equal to minus 12 over 5 times by 10 and then plus c. So that means 11 is equal to, that's going to be minus 12 times 2, which is minus 24 plus c. So therefore the plus c here is 24 plus 11, which is 35. Great, so we'll just put in brackets here that the equation for this tangent is y equal to minus 12 over 5x and then plus this 35 there. Great, now let's do the same for the tangent at 10 and 1, the bottom tangent at the bottom of the diagram. Okay, so now tangent for 10, 1. So it's really the same process. So what we're going to do is work out the gradient of the radius. So that radius there, again, which is perpendicular to the tangent, take the negative reciprocal, and we go from there. Okay, so we'll do this a bit quicker for this one because we know what to do now. So changing y with changing x for the line from the center to the point. So this is going to be difference in the y value. So 1 minus 6 for this one. So 1 minus 6, and then divide by the difference of the x values. So 10 minus 2 for this one. So 10 minus 2. So this will be minus 5 over positive 12. So therefore the gradient of the tangent will be negative reciprocal, which will be 12 over 5 for this one instead. So therefore, just make it clear in my working here, actually, that this is the gradient of the radius, just to make it clear, gradient of radius, because it's not necessarily clear to the examiner what this is there. I mean, it should be, but I'll just make a note of that there in case anyone's not sure. So therefore, the equation, let's do the 3 dots there again, equation of tangent is going to be y equal to 12 over 5x plus c. And then we can now sub in this point 10 and 1. Okay, so x equals 10. Just write that again. I'm not being very neat today, unfortunately. X equals 10, y is 1. So we get 1 is equal to 12 over 5 times 10 plus c. So we got 1 is equal to 12 times 2, which is 24, plus c. So therefore the c is 1 take away 24, which is minus 23. Okay, so now what we know, if we just do the diagram again, something like that, you had your tangent there, you had a tangent there roughly. You've got your y-axis, which is something like this. So now what we now know if we put the x-axis there as well. So we know that that point up there was, I think it was 35. Was it 35? Yes, it was 35. So the y-intercept for the top tangent is 35. Y-intercept for the bottom one is this minus 23. It's 23. So clearly, scroll up a little bit again. Clearly, the distance PQ is 35, subtract -23, so 35 plus 23, which is 58 as required. Perfect. So hopefully that process that I've gone through there does make sense. Do drop a comment below if anything did not make sense or you need clarification with anything. But otherwise, I will catch you in my next video.